Hi, my name is Dan Chavas. I'm an associate professor of atmospheric science in the Department of Earth, Atmospheric, and Planetary Sciences at Purdue University. So I study severe thunderstorms and tornadoes as well as hurricanes. I work on the physics of how those systems work as well as why we have them on Earth in general. So for example, I'm interested in why is it that the United States is kind of a global hotspot for tornadoes in particular, is one example. And the motivation for this is that if we can better understand how these systems work, we can better predict their hazards and their impacts on society, as well as how those are changing with climate change. So I work on other questions related to severe thunderstorms and tornadoes, in particular this question of climate change. How is and will climate change affect the intensity and frequency of severe thunderstorms and tornadoes, both globally? Will there be changes in the hotspots of these of severe thunderstorms around the world, and then in particular over the United States? Could there be regional shifts in the frequency or occurrence or intensity of these events? So that's an important question. Everybody's really interested in this. It's a big topic. Severe thunderstorms and tornadoes have become one of the most damaging weather phenomena in terms of economic damage and societal impacts globally, as well as in particularly in the United States over the last couple of decades. So we are interested in predicting tornadoes and severe thunderstorms, and it helps to be able to predict those. We need to understand why we have them in the first place. So that's kind of a first foundational step to why is it that we have so many, for example, so many tornadoes in North America and why there are so few in South America. It's also helpful then if we want to think about, hey, how these things will change with climate change. So when could we have more tornadoes in the future? Fewer? Will it change the regions where they occur? That depends again on understanding fundamentally, like, why are they there in the first place? Why does the climate system produce these environments that create the tornado and that can create the tornado alley that we have in North America, for example? And so if we have that basic understanding of why they occur, where and when they do, say over the United States, then that helps us to understand, say, if climate change may change how the atmosphere, how the jet stream moves around, how the atmosphere interacts with the surface. That may help us directly understand how maybe there will be regional changes in severe thunderstorms or tornadoes in the future. We've done work both on how kind of continental scale land surface roughness can matter for controlling where tornadoes may form, but there's also questions of smaller scale local topography that may affect tornadoes. And we've also shown that there's, along with other studies, that there are clear effects that tornadoes seem to be less likely to form when say land is hillier, things like that. And so that's again a place where if the atmospheric flow changes under climate change in a way that maybe moves regions where you might think tornadoes could form, are more likely to form into regions that are more forested or more hilly or more mountainous. These are another level of interactions that we're trying to understand that make studying climate change effects on these very difficult.